How do we score more than 90% marks and close to 100% in final exam? That is what you learn when you watch my videos. Since I take up questions which are based on past test papers, here is one for you. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. Here is a very special series for test preparation on trigonometry. Most of the questions are from previous test papers or from my students. Well, in case you want to learn from me directly, send an email on this particular address or you can fill a form on our website. The question here is, write equation in the form y equals to a sine k x minus p plus q when maximum is at 45 degrees, 3 and minimum is at 135 degrees minus 5. So on the sinusoidal function, we are given 2 points. One is a maximum value, one is a minimum value. You need to find the equation from the given characteristics. Make sense? So let's try to understand how do we solve such a question. Just 2 points and we need to find the whole equation. Perfect. So let's figure this out once. We are given a trigonometric function which is looking like what? So of course sine wave, right? So let me just draw a sine wave first. Okay. We are given 2 points. So minus 5 is first. So the 135 minus 5. Okay, makes sense, right? So the first point is maximum, which is 45 degrees and y value being 3. The minimum is 135 degrees. Minimum is minus 5. Correct. So let us visualize and answer our question. You don't really need to remember so many formulae. I know students spend a lot of time in remembering so many formulae, but let's visualize, understand the concept. So the concept here is that we should have axis right there in between, right? Right in the center, we have an axis, correct? How do I find the value of axis? As you can see very clearly, it is the average value, right? So this is the average value. Right in the center, middle of it, right? So how do you find a middle point? Add the y values, divide by 2, right? So we do 3 plus minus 5 divided by 2. And this gives you 3 minus 5, which is minus 2 over 2 or just minus 1. So we get average value, and this average value corresponds to what in the function? This gives you the value of q, right? It has been translated by 1 unit down. Does make sense? So we got one parameter from the characteristics of this particular given sinusoidal function. Make sense? Now let's hit for the amplitude. Okay. So amplitude is, you could do 2 ways. One is how much away it is from the axis. That is basically amplitude, right? Or you could also find again half of the maximum and minimum, right? So a minus b. But I think I prefer this value of amplitude. So we're looking now at amplitude a. So amplitude, as you can see, we know this value, average value is minus 1, right? So this is like y equals to minus 1. So if you want to go to 3, you have to go up by 3 minus minus 1, which is 4, right? So we can find the amplitude now. So let's hit for the amplitude. So amplitude A is basically the difference of maximum minus axis. So maximum is 3 minus minus 1, right? So we got the value of A as 4, correct? So we have A equals to 4. Now the most important thing is to find the phase shift, which is difficult. So let's leave it for the last. Let's get to period now. Now period, if you visualize, which you've already done so, maximum, minimum, this is half cycle. Do you see that? This is half cycle. Right? So if you extend, you get the full cycle, correct? That will be full cycle, correct? So we have done half of the cycle, and the time period is how much? Time period is 135 minus 45, correct? So the period should be twice this. Makes sense, right? So we say period is 2 times the difference between these times, which are 135 minus 45. Does make sense to you, right? So 35 minus 45 is 90 degrees, right? So the period is 180 degrees. So we know that the period is 180 degrees. Now from the period, we can find the constant K. So K is actually equal to 360 degrees divided by period. I'm writing capital P. You could write time period T also. So it is 360 degrees divided by 180, and that gives you 2. So the value of K is 2. Make sense? Perfect. So we got the value of K as 2 also. Very good. Another answer for us. So we have 3 of them. We only need to find the phase shift, which of course is sometimes very difficult for all the students to figure out. So now, see, there are a couple of ways in which you can find the phase shift for the sine wave. It is starting from here, and we need to figure out what is the starting point, right? What is the starting point? That is the whole thing. Okay. So the maximum occurs at quarter of the period. Do you see that? So what is quarter of 180? Because 180 is the total period, right? Half is 90 and then 45. So it seems really that it starts from 0 only, this one. So if you go back and look, trace out the starting point, and if I place this to, of course we have the axis at -1, so I could draw my graph as something like this, right? So what you notice here is that it really has 0 phase shift, because see, if I make this as 0, you see 45, 90, 135 and 180, right? So you have to see from where the sine wave starts, correct? Sine wave is starting from 0. So in this case, the phase shift P is equal to 0. And so we get our equation, correct? With all this, we can get our equation. Can I write down the equation here? The equation therefore is y equals to the value of A, which we found as 4, sine the value of K is 2 for us. So 2 sine waves in one period of 2 pi, x since P is 0, plus Q value is -1. Do you see that? That is how we can write down the sine function. Now a question for you. Question for you is, how do you write cosine function? In cosine function, everything will remain same except for the phase shift, right? Phase shift is 0 for sine. You can see here, it just starts from here. But if you're considering cosine function, you have to look at the maximum, which is at 45. So the cosine function will be y equals to, amplitude is same, cos of time period is same, x minus 45 degrees, because it moved 45 degrees to the right as far as cos function is concerned, -1. Do you see that? In fact, we can write 4 equations very easily from the given conditions. I could also start from here, writing a sine with phase shift of this much. You see that? Correct? 90 degrees, right? With minus sign. So now I would like you to write other two equations when same conditions are given to us. But I hope you have understood completely how do we answer similar questions. Well, in the next video, we'll take up an example where there will be a phase shift, right? That was a challenging part, but we kind of skipped it since the question involved did not have that criteria, right? So now here is another question for you, which I like you to do, which involves phase shift, right? So answer this particular question. I'll post this video soon. Thanks for your time and all the best.